everyone. Okay, from your book, page 658, the question says, find the exact value of each expression if the theta is between 0 and 90. Why are they giving me this? They're giving me this to fix the sign, or to understand that I'm in quadrant 1. And in quadrant 1, all are positive, right? Because now if I use Pythagorean identity, as I showed you, I might get plus or minus. And then I won't know which is the answer. You will know from the quadrant the signs of the answer. So here I don't have to worry about the answer. The answer is positive anyways. In question number 1 here in your book, it says if cotan theta is equal to 2, find tan theta. Well, that's also an easy one. Tan theta is equal to 1 over 2 because it's 1 over cotan theta, and the answer is positive, and that's it. Over here, how can I relate sine and cosine? Whenever you have sine and cosine, remember our lovely, very important Pythagorean identity. This is the most important one in Pythagorean because it keeps popping here and there. The sine squared, اللي هي كانت x squared plus y squared equals to r squared. So now, if I want cosine squared theta, it will be 1 over 4 over 5 squared. This is 4 over 5 squared. So cosine squared theta is 1 minus 16 over 25. So cosine squared theta is actually 9, right? I think it's 9 over 25. 9 over 25. I can use this as 25 over 25. And then cosine theta will equal to 3 over root of this. Root both sides. 3 over 5 is the answer. I'll not change its sign because we're still in quadrant 1 and everybody is positive. Also, this one needs Pythagorean identity. You can pause and solve it on your own. So again, I can directly say that sine squared theta is equal to 1 minus cosine squared theta. So sine theta is equal to root of 1 minus 2 over 3 squared. You will get the answer as root of 5 over 3. Okay. Okay. Because this will give you root of 5 over 9 and then root of 5 over 3. Okay. These are the first 3 questions in your book. I'll go to question number 4. I will not simplify today, only evaluating or finding the exact value. Here they gave me cosine and they want cosec. Remember, cosec is related to sine, not to cosine. So this question needs 2 steps. First of all, needs Pythagorean and then needs reciprocal function. Why Pythagorean? Pythagorean will help me get sine squared because sine squared is 1 minus cosine squared theta. I'll show you another way. I think I have one other way for that. No, I don't have another way. I thought it's cotan. Okay, so sine squared theta is equal to 1 minus 2 over 3 squared. If you root the answer, you will get sine theta as, you have to have a calculator with you, right? Sine theta will equal to root of 5 over 3. And then to get, now I will start using reciprocal identity, which says that cosec theta is equal to 1 over sine theta. The sine theta. Why did I write 2 cosec? Cosec. Okay, so it's equal to 3 over root of 5. As I ignored before, now, mashallah, you're grown-ups, I cannot ignore anymore. You will have to rationalize. This step is called rationalize the denominator. How? Multiply by root of 5 over root of 5, so the answer is 3 root of 5 over 5. Okay. From the second part, here we have simplify. I will simplify tomorrow when you get more used to this, because I know the beginning of it is like a shock. But wallah, it's easy. وكمان انتو you have strong bases now, inshallah. Now, find the exact value of each expression. One part from 0 to 90, one part from 180 to 270, 270 to 360, and here I will stop. Here it says, again, if cosine theta is equal to, I want cosec. Again, there's nothing to relate these two. I need to know what is sine. To know what is sine, I will do sine squared theta equals 1 minus 3 over 5 squared. Or sine squared theta is equal to 1 minus 9 over 25. Or sine squared theta is equal to 16, right, over 25. It should be 16 over 25. Just a second. 9 minus 25. 16 over 25. So sine theta is equal to 4 over 5. So cosec theta is now very easy to get. It will be 5 over 4. Over here I used Pythagorean identity, and over here I used quotient reciprocal identity, right? This is for question number 9. The answer is 5 over 4. خلاص, don't lose yourself in the middle. Know what you need. يعني ممكن some students can get sine and stop. The question was asking for cosec. طيب, over here, how can I relate sine and tan phi? Sine can help me get cosine, and then tan, في واحدة identity that says tan is sine theta over cosine theta, which is called quotient identity. And this, I can get cosine using Pythagorean identity. Okay, so I can get cosine squared theta is equal to 1 minus 1 over 2 squared. So cosine theta will equal to root of 3 over 2 if you simplify. I'll take it and start the quotient identity to get tan theta is equal to sine theta, which is half, over cosine theta, which is root of 3 over 2. So tan theta is 1 over root of 3. I will multiply by root of 3 over root of 3, and the answer for tan theta is equal to root of 3 over 3 in simplest form. Okay, I don't have to worry about the signs here because this is quadrant 1 and everybody is positive anyways. Quadrant 1 again. If you can pause and start trying to solve. For this one, I just need, obviously sine and cosine, I just need Pythagorean identity. So cosine squared theta is equal to 1 minus 9 over 25. I directly squared this. So cosine theta is equal to root of 16 over 25. So cosine theta is equal to 4 over 5, and I'm done. If you know that there's a special right triangle, that's 3, 4, 5, and you can easily think if sine is 3 over 5, cosine is 4 over 5. But anyways, this is the way. Regarding tan and sec, I have a very lovely Pythagorean identity that says tan squared plus 1 equals sec squared. This is the easiest way to this. And there's no other way, by the way. Okay? So I know that tan squared theta is equal to equal to sec squared theta minus 1. Because here in the identity is plus 1. If I send the 1 to the other side, no, actually I want to solve it for sec. Why am I doing that? I don't need that. The identity itself, sec squared, is equal to tan squared theta plus 1. So sec squared theta is equal to 2 squared, that's 4 plus 1. So sec squared theta is equal to 5. Sec theta is equal to root of 5, and you're done. The second part is asking me from 180 to 270. Okay, this is quadrant 3, where tan is positive, sine is negative, cosine is negative, and the reciprocals are the same. So from the beginning, remind yourself, this is a cosec. The cosec over here, the answer has to be negative. Remind yourself by putting a negative on the side that you will have to change the answer in the end. Okay, how can I use these? I have to get sine first, and then get its reciprocal. I'll get sine first by Pythagorean identity. Sine squared theta is equal to 1 minus negative 3 over 5 squared. So sine theta is equal to root of 1 minus 9 over 25. So sine theta is equal, this is 16 over 25. So sine theta is equal to 4 over 5 after the root. Okay, I didn't fix the sign here. I don't care. I care about the last answer, although I know that sine also is negative here, but the question is asking for cosec. Cosec theta is equal to the reciprocal. Here I used reciprocal identity, reciprocal of sine. So 5 over 4, and I have to remember to put a negative sign over here because I'm in quadrant 3, and in quadrant 3 cosec and sine are both negative. Why is this happening? Because I'm squaring everybody here, so I'm losing the negative for the cosine. I'm losing it, and I don't know now where am I. To know where am I, fix the sign of the last answer and you'll know where you are. This one, there is a lovely Pythagorean identity relating sec and tan. If you remember, that starts with tan squared theta plus 1 equals to sec squared theta. Right? Right. Inshallah, I am right. Tan squared theta is equal to 1 plus this one. Plus 1 equals to sec squared. Okay, so remember the tan with the 1 and the sec all alone. Okay, so if I want to solve this for tan, I will say that tan squared theta is equal to sec squared theta minus 1. So tan squared theta is equal to 9. I squared this minus 1. So tan theta is equal to root of 8, which is 2 root of 2. Okay, is tan positive here or negative in quadrant 3? It is positive. Just confirm with yourself in the end that the answer here must be positive and there's no problem. Or from the beginning, remind yourself that this is positive because they've mentioned the quadrant. Okay, also over here, cosec must be negative in the end. There is one lovely Pythagorean identity connecting cotan and cosec. That's cotan squared plus 1 equals to cosec squared. Remember, so this one starts with tan squared plus 1 equals to sec. This one starts with cotan squared plus 1 equals to cosec squared. So if I want cosec squared theta, it's equal to cotan squared theta plus 1. So cosec squared theta is equal to 1 over 4 squared plus 1. After rooting your answer, you will get the cosec theta, which is going to equal to root of 17 over 4. And we will remember to put a negative sign over here because it is negative. Again, sine and cosine, there's a Pythagorean identity. So cosine squared theta is equal to 1 minus negative 1 over 2 squared. So cosine theta is equal to root of 1 minus 1 over 4. You will end up having cosine theta equals to root of 1 minus 0.25 root of 3 over 2. I didn't remind myself from the beginning that my answer has to be negative, so this has to be negative because I'm in quadrant 3. Maybe we go to a new quadrant. Yeah, this is the last part. Find the exact value of each expression if 270 theta 360 means quadrant 4. In quadrant 4, cosine is positive, sine is negative, tan is negative, and the reciprocals are the same. A lovely one here, sine and cosine. So sine squared theta equals 1 minus 5 over 3 squared. You will get the answer as sine theta equals to 12 over 13. From the beginning, I know sine is negative here. The answer is negative 12 over 13. Now, tan theta is equal to negative 1. Find sec theta. Pythagorean D, tan squared plus 1 equals to sec squared. So sec squared theta equals to tan squared plus 1. So sec theta equals to root of 2. So sec theta, but sec over here, as we said, sec and cosine are both positive. So there is no problem to keep it as positive. And remind yourself it is positive because cosine is positive over here. I hope you are understanding. I wish we were in class. Anyways, now sec and cosine, there's a reciprocal identity directly. Cosine theta is equal to 3 over 5, and it is positive. There's no problem because we are in quadrant 4. And finally, finally, question number 20. I bet you love this lesson. I cannot relate cosine and cosec. This can help me find sine, because sine theta is equal to -3/5. And this can help me find cosine by using Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So to find cosine squared theta, I will do 1 minus sine squared theta, right? Yeah, 1 minus sine squared theta. So cosine squared theta is equal to 1 minus -3/5 squared. So cosine squared theta is equal to 1 minus 9/25. So cosine squared theta is equal, I bet you remember the numbers now. This is 16/25. Cosine theta is equal to 4/5. And cosine theta here is positive because I'm in quadrant 4. Just remind yourself the answer is positive. Regarding the homework, you will solve in your workbook the questions that are from 1 to 10 only. No evaluating. Not simplifying it. Workbook 1, take your time. 1 to 10, take your time and solve. And I will pick it at the end when the whole lesson is done, okay? Enjoy. Yeah. Love you. Bye.